Today our chapter is Language of Chemistry Part 3, which is the continuation of Part 2. In this we are going to know about relative atomic mass, relative molecular mass, atomic weight, calculations of relative molecular mass and calculations of percentage composition of a compound. Okay, first we'll go to this concept like introduction and then we'll go to relative atomic mass. Okay, first if you see, atoms are extremely small. They are very small and very light, and hence we cannot be weighed directly. You cannot weigh the atom directly. So there are indirect methods have been utilized to determine the absolute mass of atom. So you cannot weigh directly. There are some methods which is indirect to measure a mass of an atom. Okay, the relative mass of an atom or molecule is hence considered by considering a mass of lighter atom and relating the mass of the other atom or molecule. See, we are going to consider a mass of a light atom and then the mass of the molecule, and so we will know the mass of an atom. Okay, for that, hydrogen atom was initially chosen as the standard unit and masses of other atoms or molecules compared to it. See, in the starting stage, they took the hydrogen atom's weight and they used hydrogen for comparing other atoms' weight. Okay, why? Because that was the lightest element, and then carbon-12 atom was later in, that is 1961, considered the standard for comparison. That is the standard of comparison. So, for whatever atomic mass if you are finding out, you have to compare that with carbon-12 atom. Okay, that is a standard for comparison of mass of the other atoms or molecules. Okay, now it is carbon-12 atom. Now coming to relative atomic mass. See, relative atomic mass of an element is the number of times of one atom of an element is heavier than the 1/12th of mass of a carbon atom. See, you are taking the comparison for carbon, that you are taking off 1/12th of the carbon. So this is the relative atomic mass. You are comparing an atom to the carbon, that is 1/12th mass of the atom of the carbon. Understood? Now I will tell you again. Relative atomic mass of an element is the number of times one atom of an element is heavier than 1/12th mass of a carbon. Okay. See, for this relative atomic mass, you can tell it in a short form as RAM. So that is like is equal to mass of one atom of the element, divided by 1/12th mass of one atom of the carbon. Okay, you are taking the mass of one atom divided by 1/12th mass of the carbon atom. This is how to do. This is what relative atomic mass. Okay. Next. Now coming to gram atomic mass, or it is also known as gram atom. See here, the relative atomic mass of an element expressed in grams. Here what you are doing is you are just expressing in the unit of grams, and that is known as gram atomic mass or gram atom of the element. Okay, atomic mass, that is relative atomic mass, is expressed in gram, that is known as gram atomic mass. Okay, next, relative molecular mass. This is in the short form you can tell RMM. This is element or a compound in the number of times one molecule of the substance is heavier than the 1/12th of the mass. See here what happened there. Atomic mass is, relative atomic mass is, atom's weight is more heavier than 1/12th of the carbon-12. Here, the element or a compound is the number of times one molecule of the substance is heavier than the 1/12th. You are comparing the molecule here. Molecule of a element or a substance. You are taking a molecule and comparing to the carbon, that is 1/12th mass of the carbon, which should be heavier. That is relative molecular mass. In here, relative molecular mass, you take a molecule. In relative atomic mass, you take an atom. Okay, this is the difference between our relative atomic mass and relative molecular mass. Okay, for this formula, if you see, that is RAM is equal to mass of one molecule of the substance divided by 1 by 12th of the atom, one atom of the carbon 12. There it was mass of one atom of the element. Here it is mass of one molecule of the substance. The name only suggests the difference between relative atomic mass and relative molecular mass. Okay. Now the same thing, that is a gram molecular mass. The relative molecular mass you are expressing in the unit of grams. That is gram molecular mass. Okay. Then coming to atomic weight. What is atomic weight? Atomic weight, also called as relative atomic mass, ratio of the average mass of the chemical elements, atoms to some standards. Okay, you are taking the, it is also called as relative atomic mass in the ratio of the average mass. You are taking an average mass of the chemical elements, atoms to some standard. That is atomic weight. Since 1961, the standard unit of atomic mass has been 1/12 the mass of the atom of the isotope carbon, that is C12. Okay, carbon 12. Okay, see the next, if you go on, you can know the atomic weight difference. Okay, it is nothing but it is called a relative atomic mass, ratio of the average mass of a chemical element. Okay, or else you can also take the roughly equal sum of the individual particle masses of an atom. If you add all the masses of the atom, you can get the atomic weight. Okay, then this atomic weight is expressed as simple numbers, or you can tell it in an AMU. AMU is what? Atomic mass units. Okay. Then AMU is defined as 1 by 12 the mass of the carbon 12. AMU is what? Defined as 1 by 12 mass of the carbon atom. Okay, next, atomic weight of the oxygen is how much? 16 AMU, that is atomic mass unit. On the scale on which carbon is 12, carbon is 12 AMU, oxygen is 16 AMU. Now if you take chlorine exists as two isotopes, it has two isotopes. So if you can see, that is Cl35 and Cl37. Yeah, in the ratio what? 3:1. Hence, if you take the average of those two and you take the weight, average is what? 35.43 AMU. Okay, this is how you calculate. Okay. Then, now you are calculating the relative molecular mass, or you can also tell it as molecular weight. First, relative molecular mass is calculated by adding together a relative atomic mass. So, in molecules you have atoms, right? To calculate that mass, you have atoms in them. So, this is what relative molecular mass is calculating by adding together the relative atomic mass, that is atomic weights of all the atoms present in the molecule. Okay, here is some examples you can calculate, how to calculate. Okay, calculate the relative molecular mass of nitrogen oxide, that is NO2. So, for that, first you have to know the atomic weight of each element in that. That is, nitrogen it is 14, oxygen is 16. Okay. So, for that, what do you tell next? What is the method? See, I will show you. Molecule of nitrogen dioxide. First, you have to know atomic weight of nitrogen plus you have oxygen 2 moles. Yeah. So, you have to take 2 into atomic weight of oxygen. So, 14 plus 2 times of 16 is 46. This is how the molecular weight of NO2 comes. Okay, understood how to calculate the relative molecular mass? You have to add all the atomic weights. To calculate molecular mass, you need atomic weights of each thing. Okay. Now, calculate the relative molecular mass of ammonium sulfate, that is NH4 whole 2 SO4. Okay, for this you have to calculate the molecular mass. First, what you have to know? You have to know the atomic weight of nitrogen, hydrogen, sulfur and oxygen. Nitrogen is 14, hydrogen is 1, sulfur is 32 and oxygen is 16. Okay, method if you see here. Okay, molecular weight of ammonium sulfate is, you have what? NH4 2, right? So, you have to take 2 times of nitrogen and 8 times of hydrogen. Why? Because NH4 whole 2, 4 2 is 8, and you have to take sulfur atomic weight and atomic weight of oxygen. Okay, 2 into 14, 8 into 1 plus 32 and 4 into 16. Okay, if you take all the thing and add, you get answer is 132. This is how to calculate molecular mass of anything, any substance or compound, element, everything. Okay, this is how to calculate. For this you need atomic weight of all the things. Now we will know about calculation of percentage composition of a compound. In that compound, how much percentage each atom is there, that you have to calculate. Okay, for this first you have to find out molecular weight, as you have learnt in the previous slides. So molecular weight you have to calculate. Then for that you have to find out the percentage. So here I will show you how to do that. Okay, first calculate the percentage of carbon dioxide they have given. So for carbon dioxide you are calculating molecular weight, that is atomic weight of carbon plus 2 times atomic weight of oxygen, and you get 44 as a molecular weight of carbon dioxide. Yes, 44. Now 44 gram of carbon dioxide contains how much? 12 gram of carbon. Yeah, atomic weight is how much of carbon is 12. Yeah, so 100 gram of, so percentage you will always take to 100. Yeah, so 100 gram of carbon dioxide contains, you have to divide 12 divided by molecular weight. Yeah, you have to divide and you have to multiply it by 100. You get 27.27. Same thing you have to do it for oxygen. Oxygen, 44 gram of carbon dioxide contains 32 gram of oxygen. Why? Because you have taken, here it is O2. You have to multiply 16 into 2. And 100 gram if you take, you have to multiply this 32 divided by 44, that is molecular weight, and you have to multiply with 100, you get this percentage. So in the compound of carbon dioxide contains 27.27% of carbon and 72.73% of oxygen. This is how to calculate the percentage in a compound. First you have to find out the molecular weight, and you have to take each atomic weight and divide that by molecular weight, and you have to multiply that into 100. Okay, this is how to calculate percentage composition. Next, here one more example is there. See, calculate the percentage composition of sodium hydroxide. Sodium hydroxide, for this you have to know atomic weight of sodium, oxygen and hydrogen, and you have to find out molecular weight. You have to just add all the atomic weights. Okay, that is sodium, hydrogen and oxygen. If you add, you get molecular weight is how much? 40. So molecular weight of the NaOH is 40, and 40 gram of NaOH contains how much? 23 gram of sodium. So for this you have to multiply 23 divided by 40 into 100. You get 57.5% of sodium. And same thing, if you divide 16 divided by 40, you get 40% of oxygen. And for hydrogen, if you take 1 by 40 into 100, you get 2.5% of hydrogen. So in the compound sodium hydroxide, it contains 57.5% of sodium and 40% of oxygen and 2.5% of hydrogen. This is how to calculate the percentage composition in a compound. Okay. Thank you.